Welcome to AI at UNSW. We've got a celebration today for some of the fantastic work going on in AI at UNSW. Let me begin by paying my acknowledgements to the traditional owners of the lands upon which I'm meeting. That's the Gadigal people of the Eora Nation, and extend those respects to the traditional owners of the lands upon which you might meet in. Welcome everyone. I see that we have people joining us from around the world. I recognize a few names just now logging on from Europe. So welcome whatever time it is for you. We have a great lineup today. I should say it is only a snapshot of some of the AI research going on. We wanted it not to go on for too long. So we only have a few people, a few of the academics, a few of the PhD students represented. There are many other people working on AI at UNSW that we could have included, but unfortunately, we would have gone on all day and all night if we had. So just treat this as a flavor of some of the work. And I think what you'll take away from this afternoon, if it is afternoon for you, this morning if it's morning for you, is just the breadth and depth of work going on in AI here at UNSW, and hopefully in a future years, next year, perhaps we're going to be able to welcome you in person once we're on top of the pandemic. So that's enough for me for now, and we'll begin with our first invited speaker, our newest AI professor at UNSW, someone who doesn't need any introduction, because certainly to anyone in AI, which is incredibly well known to everyone. But here at UNSW, we're very privileged to welcome Marianne Williams, who's recently joined UNSW from UTS and has done some remarkable work over many, many years in AI. And she's going to spend the next half an hour or so telling us about her vision for the future of AI. So now we need to hand over to Marianne. Marianne.
Ooh, wonderful. Hi guys.
The floor is yours, hopefully.
Except the host needs to disable my screen sharing. Toby, I get a message that says the host has disabled my screen sharing. In fact, you've disabled it for everybody.
Okay, let me.
I think you're showing a certain amount of bias here.
Okay, you should be able to say now.
Okay. Woo. Awesome. This is my secret message. Okay. How's that?
That's great.
Okay. Thanks for inviting me, Toby. It's great to be here. Now, we all know that AI is profoundly altering the world and raising important questions about society, the economy, and governance. And, you know, I'm not here to predict the future or build you a roadmap. But what I hope is that I can add a little bit to your compass and maybe highlight some areas where you can take action today. So I've spent the last, well, I don't know how long, 30 years working in AI, and the last 20 in robotics with my team at UTS and previously at the University of Newcastle. And more recently, in the last 5 or 7 years, we've been focusing on social robotics and human-robot interaction. We sort of, well, if you do social robotics, you've got to do robotics for a start. But we also focus on, you know, emotional intelligence, social intelligence. How do you get a robot to persuade people to open a door for them if they don't have an actuator that could actually do that? We compete internationally at RoboCup, and we are currently the world champions in the Social Robotics League that uses Pepper robots. We work with a wide range of industry partners, putting robots out into the real world to see what happens. And this is where design comes in. In robot soccer, you cannot predict a game whatsoever. You just have no idea. I mean, there's just an infinite number of ways the game could go. And similarly, when you put a robot or indeed any AI out there in the world, you can't predict it. So, you know, you've got to have a framework that you can use to test, build prototypes, test, repeat, iterate. And we focus on safety, number one, security, privacy is super important, and then the legal and ethical issues that surround, you know, putting a robot out there. Now, to get started, because I know you've all had lunch or maybe eating it now, we're going to play a game, okay? I'm going to show you some numbers, and I want you to write down straight away what number you think observes the rule that these three numbers observe, okay? So there's an underlying rule. Your job is to actually try and guess that rule, but you may want to ask if the number that you write down right now is actually, or does satisfy the rule or not. So I've made it super, super easy because we don't have time. Oops. So here are three numbers, okay? They all satisfy the rule. Now, I want you to write down the rule if you know it straight away. I have made this pretty easy. And then alternatively, write down a number that you would like to ask me later if it satisfies the rule. Okay, everybody done this? Okay, just write down a number or write down a rule or both, okay? And we'll circle back to this later, okay? But please do it. You absolutely have to do it. Everybody happy? Cool. Now, today I'm going to sort of lift the lid on AI, talk about its performance and its impact, really emphasize the connection between the adoption of AI and trust. And if we don't get adoption, we don't really have anything, okay? So adoption is actually the key to, you know, an AI future where we get all the benefits, all right? And the way to adoption is trust. Toby will be talking about trust later. So, you know, what could possibly go wrong with AI? Well, we've uncovered a few things already. And then what are the challenges? And then finally, how can a design stance actually help us figure out what to do next? Because, you know, there's a lot of talk, there's a lot of controversy, but it's time to do things. So first of all, AI, these are systems that use symbolic and sensor data to reason, decide, recommend, act, and adapt, you know, in the same way, not in the same way, but get the same sort of outcome as people. So we want human level AI, okay? And deep learning has been the big game changer. About 5 years ago, it really started to outperform people. And where are we? Where is AI in this sort of design process? Well, we've been round and round the prototype testing cycle many, many times. We've iterated so many, many times, right? It's quite mature, let's say, at least in the lab and from the perspective of researchers. The promise of AI is performance, right? We're promised autonomous vehicles, and the reason they're going to be great is because they will drive better than humans, and there'll be less accidents, less deaths. I mean, if that's not the sale pitch, what is it? You know, it's really telling us that we can save lives if we adopt this technology. And if that turns out to be false, well, who will really adopt it? Well, you know, there may be secondary reasons for why it might be useful, but even in terms of sort of the amount of traffic we have, it turns out that autonomous vehicles aren't going to alleviate all of those traffic jams that we see on US freeways at all. It will have a small impact, but not a game-changing impact. So how many people in this audience can do a backflip? I'm sharing my screen. I should get rid of that. I'm going to turn the sound down. Okay, well, you know, here's a robot who achieved this a few years ago. And this isn't just a piece of software. This is, you know, quite a significant piece of machinery that is able to do what most humans can't. So what is it about performance? Well, you know, traditional machine learning of last century sort of tapered off. You know, we kept giving it more data, but its performance sort of plateaued. Similarly, human expertise plateaus. You know, after 7 years of medical training, you know, your performance increases a little bit, but not hugely. But what we discovered with deep learning is that the more data we give it, the better it learns, and we haven't found its ceiling yet. This is quite a huge thing. And what does it mean? It means that, you know, this is powering AI, and one of the impacts is, okay, we can change the way we do science. We can ask different questions. We can ask questions that we couldn't answer without AI. Andrew Ning, he sort of came up with this really cool idea that AI is the new electricity. And what does he mean by that? He means that a good way to think about AI, because it is complicated, is electricity. Electricity is about 100 years old. It wasn't a singularity moment. It has affected society and business, you know, over the 100 years, and it's still doing so. I mean, it's allowing me to present today on this computer. And I think it's a very enabling way to think about AI, because otherwise you just get lost in the complexity and the applications, and this sort of helps you. Now, why is AI doing so well? Because it's outperforming people. We're coming up with faster, cheaper solutions. These solutions are repeatable, they're scalable, they're transformative, they have broad impact, they're reshaping everything. They're, you know, AI is multi-purpose. I mean, it's also sort of dangerous, as we'll discover. It empowers and augments people and their decision-making. Interestingly, AI has uncovered many, many flaws in human society, from systemic bias, right? Deep-seated bias. And one of the most deep-seated bias is gender bias. And also how easy it is to fool people, to distract them, to get them addicted to certain, you know, dopamine hits, etc. But it's also uncovered its own dangerous and harmful side. There's a direct correlation between AI adoption and superior business outcomes. There's a ton of investment going into AI, but 2/3 of people don't think companies are working for their benefit. Now, this is going to undermine AI adoption, okay? Companies now and in the future will have to demonstrate that their AI is actually beneficial to the customer. It's not just helping me go to a new level in a game by actually lowering the bar. No, it's helping me save for that house that my family needs. People worried about their jobs. So, you know, there's a much broader impact to AI than its performance. And here are 4 things that a team at UQ and KPMG uncovered about what underpins trust in AI for Australians. And the first one is, if you believe that current regulations, laws, and safeguards are sufficient to protect, then it is very likely that you will trust AI. And that is the strongest predictor. Interesting. It also gives us a reason why, you know, Facebook and other sort of social media companies may be trusted more than they should be, simply because Australians think, you know, Facebook wouldn't be out there if it was dangerous, right? Because laws protect them. The uncertainty, you know, just that predictability piece. And most Australians believe that AI will create more jobs. And if you do, then you like AI and you want to adopt it. And then just simply experience and understanding. So, yeah. Now, what could possibly go wrong with AI? And I think there are 5 main areas, you know, the economic risks, social risks, security risks, safety risks, and privacy risks. And I do think it helps to categorize them instead of just sort of having a long laundry list of all those risks. So in terms of safety, you know, AI makes mistakes. And when it does, it makes big ones, or, you know, unintuitive for us humans, right? You know, you can see a whole bunch of chihuahuas there, and we wouldn't confuse a chihuahua with a muffin. Or, you know, AI has been shown to confuse, you know, a machine gun with a helicopter, this kind of thing. Now, when it makes a mistake like that, we would like to know why. Now, if we pointed to, one of these muffins that really looked like a chihuahua, and I was looking at it from a distance and I said, hey, look at that chihuahua, you would say, that's not a chihuahua, that's a muffin. And I would say, oh, it looks like a chihuahua from here because of, the eyes are there and the nose is there. Like, I can come up with an explanation if I make a mistake. And we do this, in sort of social dialogues all the time. Privacy. So, there's a big thing around tracking people, the surveillance economy. How are we going to sort of reel that in? And in some places, facial recognition, even for the police force, is banned because of the risks that it raises and the sort of underlying problems with bias, etc. And then the economic ones, jobs are changing. Yes, more will be created. But what about those jobs for which people cannot retrain? So, you lose your job because an AI can now do it faster, cheaper, and better than you. But, what's your possibility of retraining to get one of these new jobs? I mean, that's the real problem. It's not whether we're going to have a net increase in jobs or not. It's whether we can retrain the people who put out of jobs into these new jobs. And that is very non-trivial and probably unlikely to happen. So what matters there is how quickly it's going to happen and who is actually affected. If older people are affected, well, it's less of a problem if AI takes a long time to create these new jobs. If it's younger people, and the horizon is sort of shorter, then, that is really going to be a serious problem. We know that AI already creates equality and equity risks. And then there are social risks. Okay, there's a lot of exploitation. Businesses are out there to make a profit, to increase revenue, to create shareholder value. They're not necessarily looking out for every single customer. Okay, and there are good reasons for that. But at the end of the day, businesses are allowed to operate to help society, not to exploit society, right? To create value for society. That's why we give them a license to trade. Are they living up to this? And security. So, if everything is digital, then AI can be used to exploit people. Again, people make a lot of mistakes. We're known to have a lot of cognitive bias. I'll talk more about that in a moment. And then, governance and policy. So they're the risks. And then, okay, what are the challenges then? Well, there are a lot of challenges around governance and policy. How are we going to manage these risks at this level? And we don't want to kill innovation, but we certainly want to contain the risk. We want to mitigate the risk. We need to manage those risks, but not at the detriment of innovation itself. And that's a very hard kind of balance to achieve. And we are a long way from achieving it. So, how can we design and deploy digital ID systems that sort of minimize the exposure of our data? And, we see failings just in society and business today without sort of AI out there making fairly context-free decisions about us. And, there's obviously big interest in spreading or mitigating the risk of disinformation. And more recently, the big one is antitrust and anti-competitive behavior by these big companies. Okay, and then power and access. A lot of the big AI companies today wield and exercise tremendous power, and they are doing what governments used to do. They kind of have a dominance in markets and more or less monopolies. Okay, this isn't good for society. And we have access problems. We've seen just through COVID how women and marginalized groups are much more impacted by access to services, access to jobs, access to opportunity. Even in Australia, you know, there's a big discussion around why is the government pumping so much money into a male-dominated industry like infrastructure. And then education and training. And, you know, I think there's two important aspects of this. One is training engineers to be more aware of these sort of risks and challenges. And then there's all the other professions and all the other disciplines that need to understand more about AI, especially if you go back to those 5 reasons why Australians would trust AI. Okay, it's they need to understand it. You know, if you understand something, then you are, and it is you know, beneficial, then you're more likely to adopt it. I'm trying to get rid of Pablo's here. All right, now I want to now focus, I can't focus on everything in the last few minutes, on how can we design and develop responsible AI. This, I think, is a challenge that in terms of a vision of what we might do at UNSW, one that we could tackle and have a really big impact. I think the education piece is one as well, but it's more obvious what we ought to do there. I think responsible AI, there are many more question marks about what do we do and how do we do it. And this is where I think taking a design stance can be very helpful. So what do we mean by responsible? Well, we mean all of those things. We want AI to be safe. We want it to be secure. We want it to respect human rights and the rights of all humans. We want it to be beneficial, okay? And we know in order to sort of achieve trust, it needs to be transparent, accountable, fair, explainable, all right? Okay, now there are a lot of principles out there. I mean, Microsoft has one, Google, Facebook. So industry have them, you know, CBA have them, our companies in Australia. And then, you know, groups like the Future of Life Institute, the Partnership on AI. And Luciano Floridi and Josh Cowles did an analysis of these 6 principles, or these 6 groups principles that they developed, and they came up with sort of common areas, all right? And they sort of say that the first 4, benevolence, non-malevolence, and autonomy, justice, are basically part of every kind of ethics framework, bioethics, you name it. Explicability is something unique to AI. And part of it is because AI is going to be doing far more than any technology. I mean, think electricity here. In 100 years, AI will be everywhere, making a lot of autonomous decisions that affect all of us. And so we will want this requirement of being able to ask why. You know, it's unlikely AI will be not making, you know, 100% correct always in every situation, in every context. So therefore, if it can make any mistake, we need to know why, and it needs to be accountable. So explicability is super important, but there's a real problem here, and that is there's a trade-off between the accuracy of prediction and the ability to explain. Okay, now in the sort of symbolic AI, it's pretty strong. People build these models, people understand these models, and when the system, you know, gives an outcome, you can say why, and that might be retracing the rules, or, you know, you can also embed rationales into this sort of reasoning very easily. But deep learning and many other sort of machine learning techniques don't offer this ability to dig deeper into the model in a way that humans can understand it. Yes, we can sort of identify, you know, what features dominated the particular, you know, decision, but that's not very satisfactory. And it won't be, because if, you know, your loan has been declined, you want to know why your loan has been declined, not why people like you have been declined. So, you know, it's not really going to be very satisfying. Also, you can't expect users to understand what these features mean. I mean, deep learning models can use millions of features, right? So it may not even be possible to identify the top 3. But, I think there is a question about how valuable that is as an explanation to ordinary humans, and even the people who built them. I've spent 20 years building robotic systems, and, once you sort of set a robot free, you can't really predict what it's going to do. And if it does something, you're only guessing, why did it look left at that particular time? Well, maybe it saw a ball go that way, but really you don't know. And sometimes robots delight you because they do something that's kind of interesting that maybe a human wouldn't have done. But again, in those novel situations where a novel solution comes up, you immediately want to evaluate that solution. Is that actually a good approach? And you need to ask why. Now, you don't need to ask why for everything, that's for sure. But there is a large class of problems for which explainability is crucial. And unless we can find a way to address this trade-off, so as the accuracy goes up, we want the explainability to go up. And that's why there are recent calls to come up with whole new ways of doing machine learning and AI. So where are we in this sort of governance or risks and challenges? Well, I think we're not very far along. We haven't even defined the problem, okay? We've ideated, we've got a few, principles out there. But what about practice? How can we bring these principles to practice? I think we can agree on principles largely. I mean, that study I showed you came up with 5 that are common and, fairly uncontroversial. But now, how do we put those into practice? And I think that there are some hints. I mean, the first one is a lack of diversity in AI design. I mean, in Australia, there's only 22% participation of women in AI. And that's a real problem for us, because it means that the solutions we're getting are not as good as they could be. And they're certainly not as robust as they should be. I feel like the systems that are out there lack an appreciation and a respect for humans, not just in outcomes, but in the way that we make decisions ourselves. We've identified, more than almost 200 cognitive bias, systematic errors that the human mind makes on a regular basis, okay? And there is a tendency for everyone, including me, to think everybody else is biased, but I'm not. I'm not, biased or discriminatory against women. I mean, I've convinced myself of that. I like dark-skinned people. I have them as my friends. I go to China. I mean, there's a lot of ways to justify why you're not biased, but guess what? You are biased, and so am I. And then there's a lack of understanding about the unforeseen consequences. You may have seen earlier, I had the headline of the woman who was taking a selfie, got a bit close to the cliff here in Australia, in Victoria, on the weekend, and fell to her death. I mean, no one would have realized that, social media would have led to that, maybe. So these are obvious gaps that we can really begin to take strides towards. Now, let's get back to our guessing game. So these were our numbers. Now, if you gave me a number like 16 or 32 or 64, okay, then, and most people tend to, I've played this game many times, then what you would be doing is confirming a rule that you have in your head as a power of 2. So that's a good illustration of confirmation bias. So if you've put down any of, power of 2 as a number you want to test to see if it satisfies this rule, then that is a clear indication of confirmation bias. And I was actually in the D school in Stanford, and someone played this game, and I fell into that trap, and I went, oh my God. And that was a real wake-up call. And I think everyone's got to get that wake-up call somehow. So, someone might have asked 0. And if they did, I would say, no, it doesn't satisfy the rule. Someone might have said 7. And I would say, yes, 7 satisfies the rule. Someone might have said -7, and I would say no, -7 doesn't satisfy the rule. And the rule is positive non-zero integers. And so I wanted to play this game because if I say confirmation bias is a problem, you guys will say, oh yeah, it is for everybody else, but not me. But hopefully some of you did fall into that trap. And many of you may have seen this before. So let's look at cognitive bias now in the last few minutes. I mean, there's almost 200 identified ones, you know, anchoring, where people are over-reliant on the first piece of information they hear. You can get people to pay more for a product by just talking about the temperature. You know, if you want someone to pay, you know, $65 for something, you talk about the temperature of the day being $65, and that actually works. Overconfidence, and this is where scientists really are vulnerable, okay? Also the confirmation bias, all right? And we see this in each other, we see this in, you know, media bubbles, in politics, everywhere, okay? So they're real. And so what can we do to build more responsible AI? That's what we're focusing on here. And I think the first step is accept you are biased. If you're in denial, if you think you're not biased and, you know, you can be objective, you're not subjective, and when you're looking at your data, when you're looking at your processes, when you're building your models, you're not biased. Instead, you should be challenging yourself and ensuring that, you know, your decisions, design decisions, are not biased. And there's a very high likelihood they are. And you need to practice this art of identifying and challenging your own bias, and your life will change. You need to develop your skills in recognizing bias in others, and then figuring out how to reduce it, mitigate it, and manage it, not exploit it, okay? There is a culture in business today to identify bias and to exploit it. And I think we need to turn that around. And one way to do it is to ensure that developers really get the, you know, the power of understanding human bias. And, you know, use this new knowledge that you have, or deeper knowledge if you've already started down this road, of achieving more responsible AI. And go out and build and test prototypes. Take a design stance. Stop talking about the problems, the risks, the challenges. You know, do something. Build a prototype for responsible AI and see if it makes a difference. See if it makes a difference, you know, in the science world, but also in the business world. And now I'm not sure we have time for questions.
Well, we have run over, but I'm going to take one question out of the chat just because I think it's so important. Dave B has asked, do we have tests for determining biases for an AI and even actually for humans?
No, but we do have some sort of clues, but this is the area that we need to really develop, and we need to put that in our curriculums for training, not just computer scientists, but everyone at universities and even schools. So there are hints, okay, you know, and some of them might be to remove certain features like gender. But this, you know, it's a simple kind of approach, and it often doesn't work because you can guess a gender from other features, number one, but also removing features might actually degrade the performance. So I think, you know, there's lots of different biases as well that you need to understand. There's sort of the data in the bias, their algorithms can be skewed as well. And so I think, you know, AI has done a great service to society by having us talk about bias without being threatening. You know, we've seen bias before when it's really overt, you know, you see it. But to call somebody out on bias, wow, that's a big and difficult thing to do, because first of all, they don't see it themselves typically. It is unconscious. And it's, you know, so what we need is people, you know, using introspection for themselves, because it's quite hard to call out on another human. You know, consider a judge, you know, and we've found that judges are highly biased. But we can call out bias on an AI algorithm. So here we have a sandbox that we can play in to learn more about bias, how to remove bias, and that can be, removing whole swags of data or designing for new data.
Wonderful, Marianne. Thank you so much. That's been a fantastic talk. I'm just reminded of a story a decade or so ago. I was using someone's face recognition software that was they were using it to identify gender, and it kept on recognizing me as a woman. This was 10 years ago when I had more hair, and so I asked the author, and he told me, "Well, you smile too much." And its bias was that it thought smiling people were more female than male.
Yeah.
So
I mean, I think when it comes to bias, there's an interesting computational story there. Prototypes, we've got Verneuil tessellations. We find them very quickly. So, we need to kind of do more processing to not take those easy solutions, which are problematic.
Great. Well, that was a wonderful place to start and a wonderful reminder of the human in AI. And it is so fantastic to welcome you to UNSW, Marianne. And I'm really looking forward to working with you on that wonderful vision you have for developing responsible AI.
Thank you. I'm super excited to be here.